सर आपका माइक बंद है।
Hello everybody. Now I am audible.
Yes sir.
Okay. Thank you. So today we will discuss about the designing concept of the filter, and after that we will discuss how the architecture of that design filter will be achieved using the concept of the FDA tool, that is the filter design and analysis tool. As we have discussed in the previous lectures, that if we have to design the filter using the FDA tool, that is the filter design and analysis tool, then for that purpose we have to write the FDA tool in the command window, and then we will press the enter button, and after that the dialog box of the FDA tool, that is the filter design and analysis tool, will be opened. And in that dialog box there will be the different section. The first one is the current filter information, in which we will here get the information related to the structure, order and stability of the filter, as well as the source of the filter here. And there are the facilities of the storing the filter designing concept or the filter management. And in the second one there is the concept, that is the dialog box related to the filter specification, and that is graphically represented here, that describes the pass band edge frequency, stop band edge frequency, attenuation in the pass band, attenuation in the stop band, as well as the sampling frequency. Now there is a third window, and the third window describes here the response type, whether we are interested for the low pass or the any other type like the raised cosine, half band low pass, Nyquist, inverse sync low pass. And the another section of this one is the related to the high pass, that is the high pass, half band and inverse sync high pass, and band pass, band stop. These are the four sections which can be selected for the purpose of the designing of the response type. And the fifth one is additional, that is the differentiator. And in the differentiator there are the different subsections, that is the differentiator, multiband, Hilbert transformation, and arbitrary magnitude and arbitrary group delay, peaking, notching, etc. here. These are the five sections that belongs to the response type here. And in the design method, after that there is a design method for that particular response type, and we have to select any one design method, either the IIR, that is related to the here the recursive structure, or the auto regressive method, and the this one is the second one is the FIR, without feedback, or the average moving filter here. And in the IIR filter there are the different methods that are used to design the filter. If we are interested in the flat response, then we will select here the butterwork. For example, if we select the butterwork, then see here that this is the structure that is specified here, that is pass band is has the flat response, as well as the stop band is has also flat response here. And in the there are no ripples in the pass band as well as in the stop band. Since we have selected here the band pass, and now suppose we select here the low pass, then we will find that flat response in the pass band as well as the flat response in the stop band, and there is a gap between the pass band edge frequency and the stop band edge frequency, that is named as the transition band. And another method of the IIR filter, like the Chevyshев one, in which there are the ripples in the one that is pass here the pass band, and we have to define the ripples in the pass band. Chevyshef 2, in that case we have to define the ripples in the stop band here. And elliptic, that is elliptic both has the ripples pass band as the stop band. Hence we can select any type of the design method for the IIR. Similarly, in the case of the FIR, there are the different methods: equiripple, least squares, window, constant least square, complex equiripple, maximally flat, least PF norm, constant equiripples, generalized equiripples, constant band equiripples, and interpolated FIR filter. And if we have, and we have also discussed that if we can design the filter using the different types of the window, and these windows will be described by the mathematical equations, and we can here the represent those mathematical equation in the graphical form using the MATLAB command. And in the toolbox also we can see the different types of the window here. Now suppose we are interested in order to see the here the window, then if we have selected any one particular window, suppose we select here the black man window, and we are interested to see it, then view, here the view the window, here we will see the response of that window, that is the specification of that window, magnitude response in time domain as well as in frequency domain. And for that purpose we have also used the command of the window visualizer tool here, and that can be here used, that can be displayed with the help of this FDA tool also, by selecting the particular window and then by using here the view command. Okay. Now suppose we are interested in order to design any filter, and for example say now we are just going to consider one example, and we are interested for designing of the low pass filter, and the filter is the FIR. So what will be the response type? Response type will be naturally the low pass, and here we in the design method we have to select the FIR because we are interested in order to design the moving average filter here. And which method has to be selected, since we are aware, and with the window method we have done some theoretical concept of the window method, so we will select here the window method. And now we have selected the window method, then we have to select here the order. What should be the order, whether we are interested for the minimum order, or we have to specify the order. Specify the order means for the given specification we have to derive, we have to calculate the order, and from that calculated order we have to select the next higher integer value. If that order is integer, it's okay, otherwise we have to select the next higher integer value, and that will be the specify order. Here we will put that value here. Now suppose we are interested for the minimum order here, then for the designing of the filter, then we can select the minimum order. And again we are coming to this one, that is the which window has to be selected. Here the window is the black man, and other windows like the say we select here the first Hamming window here. Suppose we are interested in order to design the FIR filter using the Hamming window. As we know, if we are going to design the FIR filter, then that filter will be described by this frequency specification. But what is the drawback here? That when this will be transformed into the time domain from the frequency domain, what will happen? There will be infinite range of the time. That is, it will exist for the infinite range of the sequences, and that is not physically realizable. So in order to convert that specification for the physical realizable filter, it has to be multiplied by the window, and there are the different windows having the different shapes, means different approximation and the different concepts. So for that purpose we will select here the windows according to our need, or according to our requirement, or according to the given specification. So suppose we have selected here the Hamming window, and again if we are interested to see the performance of the Hamming window, means whether we are going to select this window after some comparative analysis of the main loop width and relative side lobe attenuation and the leakage factor. If we are not satisfied with this window, then naturally we can update here the filter. Suppose we have selected this filter here, this window here, to design the filter. Now here say we are interested to design any filter, since we are just considering here the example, we have not considered any particular range of the frequency. So we will select here the frequencies by default by any value here. For example, say it is the sampling here the sampling frequency is given 48,000, and the here cutoff frequency is 10,800, like that here. Now if we design this filter, then for the purpose of the design, after designing we have, for the purpose of the designing we have to select this one, design filter. When we design filter, when we select design filter, then what happens? See here we have specified the order. So order is given 10 and it is a direct form FIR filter. Once again we will discuss some concept of the architecture here. See, I think you people have gone through the previous lecture related to the architecture of the filter. Whether you people have gone through that lecture? Yes or no? It is a lecture that is related to the architecture of the FIR, architecture of the filter here. And in this lecture, we have discussed what are the different architecture. We have described that from given specification. That is the if the specification is given, or we have derived here the mathematical model. Then from that mathematical model, how we will derive the architecture of the filter. Say this is the DSP algorithm here, and DSP algorithm is described with the help of the input and output here. And say after this one, this is the algorithm here, and we have also described how mathematically this algorithm can be described using the functional behavior for the architectural design here. And behavioral language or the behavioral graph representation is represented either using the graphical representation or the languages. We are using here the graphical representation. And for the architectural designing concept, we can use the different types of the graphs like the block diagram, signal flow graph, data flow graph, and dependence graph. Block diagram describes the architecture, signal flow graph gives the information about the flow of the signal here, and data flow graph, it describes the one iteration of the algorithm. Dependence graph describes the complete algorithm of the DSP algorithm here. Now see here, we have also described that for the purpose of the to draw the architecture of a filter, there are need of the adders, multipliers, and the memory. And the adder is represented by this simple, multiplier is represented by this one, and delay, that is the memory, is represented by with the help of the delay or 1 bit information, 1 bit storing element. Now, if we are interested in order to draw here the architecture for this graph here, then we can draw this one directly from this graph here. Say yn is equal to summation with the negative sign that has been shifted from left side to the right side. K is equal to 1 to 1 ak yn minus k plus summation bk is multiplied by x n minus k summation is k is equal to 0 to m. Now for the first term here, that is this one, positive term, can be represented by this one, that is the input xn, and then it is multiplied by the b naught, and after delay this will be multiplied by b1, and again delayed and multiplied by b2, like that, and the last term will become here the bm here. Similarly, for the second term we will consider from here, that is the c here. From the yn we can select the yn, then after delay yn minus 1 multiplied by minus a1, and again delayed, then minus multiplied by minus a2 here, like that, and the last term will become here, the last one will become. Now see, there are the two sections. One is the related to the first section, that is the positive one, and this one is to the negative one here. Now if we see, then we'll find one is the h1 and the second one is the h2. So if the total filter is the represented by the hz, and it is the h1 and it is the h2, then hz is nothing but it is represented by h1 multiplied by h2z here, that is in cascade manner here. And now if we change the location and position of the h1 and h2, then what will happen? Performance remains same. So in the next diagram we are just changing the structure here, that is the h1 and h2 here. The h1 and h2 both position has been position of both will be changed, and the first will be h2z and after that h1z, but the performance will remain same here. See, this is the total architecture, and here we are changing the position and location of the h1 and the h2z here. Now see what happens after changing the position and location. We are just trying here the graph related to the H1Z and the H2Z. And now see here, this is the H2Z. The first one is the H2Z and second one is the H1Z. Now there is a series of the D element, that is the delayed elements are in this branch, and again followed by the same series of the delayed element. So what we can say, whatever is the signal here, the same level of the signal is at this one, and it is delayed by 1 unit, again it is delayed by 1 unit. So we can merge these two branches of the delay here. So in this one we are trying to draw the new graph related to this one after merging the two sections here. So what will happen, in place of the two series of the D, now we will get only one series of the D, that is the delay elements. So what will happen here, the again we have to see which number is larger, N or M. The larger number will be the number of the delay here. So if N is greater than M, so naturally there will be the N number of the delays in this branch here, and M towards the right side and N towards the left side, that is left side related to the Y and right side related to the XN. That is we have, because we have changed the location and position of the H1Z and the H2Z here. So what will be the graph here? Now see, finally we will draw this graph here. This is the total graph here. That is the, this is the XN and this is the YN. Now in this one there is a one series of the delay, and this is the, we have derived the two architecture here. The first one was derived directly from the equation, that's why that is named as the direct form 1, and we are getting here the second after some manipulation, that's why this will be named as the direct form 2. See here, this is the direct form 1. This is the direct form 1. We have derived directly from this equation. See here, we are getting this one directly from this equation. That's why this will be named as the direct form 1 realization here. It is this architecture is related to the direct form 1 architecture or the direct form 1 realization of the filter, IIR filter here. And for the second one, that is the second one is derived from this one after some manipulation. This is, that's why this will be known as the direct form 2 realization. So and again we have also described here the another type of the architecture of the filter having the same one, that is the cascade realization. For the cascade realization, whatever is the SZ system function, that will be broken into the first order section and the second order section, and here we will describe how the first order section will be mathematically described and how the second order section mathematically will be described, and from that those mathematical equations we will derive the architecture here. See, this is the first order mathematical model. First order FOS, first order means whatever is the order, if the odd number of the order, then the first will be the first order section and remaining will be the second order section here, and second order section will be described by this mathematical equation here. This is the first order section FOS, and now we are going to describe the second order section here. See, this is this is the second order section, and this one is the first order section. It has the maximum power of the 2, and this has the maximum power of the 1. Now using the first order section and the second order section, total system function will be described in the graphical manner here. See, this is the architecture related to the first order section, and the second one is derived here for the second order section, and this is the first order section. Now for the parallel form, we will write the total equation in this form, that is the C plus multiplied by summation with the summation AK divided by 1 plus PKZ. PK is related to the particular pole Z to the power minus 1 here, and C will be described by some mathematical equation, that is the some pure value here, that is equal to the Bn by An here, and AK is a constant here. Then after this one, we will draw the graph how this parallel form will be represented. So this will be the parallel form architecture for this filter, that is the Hz is represented as mathematically represented as C plus summation k is equal to 1 to n AK divided by 1 plus PK Z to power minus 1, and C will be described by this relation, that is the this is C is equal to the Bn by An, and AK is a constant. So here C will be represented here in the top one, and then the remaining the Hz related to the this one HKZ. HKZ related to the HKZ, these H are represented here, that is H1Z, H2Z, and like that up to the HNZ. So this is the parallel form realization. These type of the architectures have been described in the lecture which have been uploaded in your classroom. Please go through this lecture again and see the architecture of the possible architecture of a given filter here. Now we are again coming to the same concept, that is the designing. Here in the filter designing, we have selected this one, and then we have selected design the filter. After design the filter, what happens? We have designed the filter. Now the structure of the filter is the direct form 2, direct form FIR filter here. And in the FIR filter, there is no concept of the direct form 1 and the direct form 2, because in the IIR there are two series, one related to the positive terms and the second related to the negative terms. But in FIR there is only one term having the summation series, so there is that filter is named as the direct form, and the order is 10, stable yes, designed source designed here. Now suppose we are interested in order to see the different types of the analysis, and we have gone through the different types of the analysis, that is magnitude, phase, and here the pole zero plot, etc. You can analyze the different types of the pole zero plots here, and stability of the system, whether the system is stable or not. Yeah, it is related to pole zero plot, and we can also see here the filter coefficients. What are the filter coefficients? We can get the different values of the filter coefficients, that is having that 11 filter coefficient, because the order is the 10 here. Filter information can be represented here, something like in this manner. That is the filter structure is the direct form FIR filter. Filter length is 11. Stable, yes. Linear phase, yes. Type 1, and the implementation cost, that is the total number of the multipliers required is the 11. Total number of the adders 10. Total number of the states, that is related to the memory 10. Multiplication per input sample 11. Addition per input sample 10. By this we can calculate here the cost of the design filter as well as the area also here, and we can analyze. If we see here the pole zero plot, then we can say the system is stable because all the poles are lying inside the unit circle here. That's why stability condition exists here, that is stable, yes. Filter information, we have represented this one. Now see, suppose we are interested in order to see the architecture of the filter. So for that purpose, if we see here, then there are the different section here. This is the create a multi-rate filter. This is the transform the filter. This is set quantization parameter. For this purpose, we suppose we are interested in order to quantize any filter. During the time of the quantization of the filter, we will consider this section here, and this realize the model here. Here there are different realization structure. Whatever is the realization structure, that is the direct form structure which we have described here. Now suppose we are interested in order to see the architecture of our design filter. So for that purpose we have to select the realize the model. Let me. For realizing the filter, we have to select this realize the model, and then input processing. Here there are the two sections. See, override generate filter block and build model using basic elements. What are the basic elements here in order to describe the architecture of the filter? Response please. What are the basic models that are used in order to draw the architecture of the filter? I am giving you the hint. We have just described that adder and see here the filter information. What are the basic blocks? The multipliers, adders, and the energy storing elements. What are the elements that are used in order to design the model of the filter? Response please. No response. नहीं सभी लोग हैं नहीं आकाश उसका कोई जरूरी हुई थी whether you people are in the class or somewhere else.
बताइए आप लोग सर पे पूछ रहे हैं.
Okay, Abhishek Mishra. Abhishek Mishra. Abhishek Mishra, please. Abhishek Mishra, please. Unmute yourself. Yeah. Unmute yourself. Yeah. And make the video on. Make the video on. बंद कर दिया mic. Abhishek Mishra, whether I am audible? Whether I am audible? Attendance लीजिए आपने क्या? Yeah, please speak. Yeah, please speak. आदित्य पांडे. आदित्य पांडे. Okay, Abhishek Mishra is speaking, but there is problem in mic. Okay, there is no problem in mic. Okay, it's okay. Aditya Pandey. Aditya Pandey. Yep, Devchan, please mute yourself. Aditya Pandey. नहीं, उसके तो इको आ रही. आदित्य पांडे. What happening? Yes, say something, भाई. Aditya Pandey. सबके माइक पर प्रॉब्लम हो गई. अच्छा, वीडियो ऑन करिए. प्लीज ऑन द वीडियो. अनम्यूट तो करो आदित्य, तब तो माइक प्रॉब्लम नहीं आएगी. अनम्यूट अनम्यूट करो. अनम्यूट योरसेल्फ. आइए. ओके भाई, आप लोग जवाब नहीं देते हो, सब लोग शांत से बैठे रहते हो. ऐश्वर्या द्विवेदी. ऐश्वर्या, they are somewhere else. आकाश,
Yes, sir.
ओके, अमन,
Yes, sir.
अमित,
Yes, sir.
आशीष, आशीष, सॉरी अनीश, अनीश, अंशिका,
प्रेजेंट सर।
अच्छा आप दो से, अंशिका कौशल, अंशिका कौशल, अंशिका पाठक,
Yes, sir.
ओके,
Yes.
प्रेजेंट सर।
चैट बॉक्स में लिखा है सर, एडर मल्टीप्लायर डिफरेंशिएटर।
हाँ, बोलते क्यों नहीं भैया आप लोग? अंशिका हो गए और कहा अटेंडेंस कौन लेता है आप लोगों में? कैसे अटेंडेंस ले लेते हैं?
वहाँ पे सर स्क्रीनशॉट ले लिया।
स्क्रीनशॉट में क्या कोई भी एंट्री करके बैठा रहेगा? इसे वीडियो ऑन करा करिए ना। एक अंशुल, बच्चे बिल्कुल जाने नहीं दे। अनुज,
Yes, sir.
आयुष,
Yes, sir.
भास्कर,
Yes, sir.
विपिन, विपिन गुप्ता, चंदन,
Yes, sir.
देवचंद जी तो हो गए अभी इसमें।
Yes, sir.
हर्ष, हर्ष सराफ, हर्षित, हिमांशी,
Yes, sir.
कैलाश तो एमटेक है, मनीष,
Yes, sir.
मानवेंद्र,
Yes, sir.
नैन्सी,
Present, sir.
ओके, नव्या,
Yes, sir.
परीक्षित,
Present, sir.
प्रांजल, प्रांजल गुप्ता, विशैल, बच्चे, प्रियांशु,
Yes, sir.
रविंदर, रविंद्र सिंह,
Yes, sir. Yes, sir.
सलीम खान,
Yes, sir.
सत्यार्थ,
Yes, sir.
सौम्या,
Yes, sir.
शिवसागर, 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 सृष्टि, सृष्टि गुप्ता, सुधांशु, एमटेक के हैं, सृष्टि भी एमटेक के, कोई नहीं। हाँ,
Present, sir.
कोई नहीं बेटा, कोई नहीं, आप एमटेक को। तरुण,
Present, sir. Present, sir.
तरुण, तरुण BTech, तरुण तिवारी,
Yes, sir.
उमेश कुमार,
Yes, sir.
उत्कर्ष, उत्कर्ष, ठीक है, उत्कर्ष,
Yes, sir.
वैभव, वैभव एमटेक के हैं, कोई नहीं।
Yes, sir.
वैशाली में कोई नहीं, कोई नहीं। वाशु,
Yes, sir.
Vipul,
Yes, sir.
योगेश्वर।
Yes, sir.
ठीक है बेटा। क्या बात क्या है, आप लोग सुनना नहीं चाहते हो कि हम सुनाई नहीं पड़ते हैं? हाँ, क्यों भाई? बच्चा पार्टी, कोई प्रॉब्लम हो तो बताइए। हम तो यहाँ से बता, हम प्रयास कर रहे हैं, आप भी तो कुछ प्रयास करो, ज्यादा ना कुछ करो, सुनो ही भाई। इतना भी नहीं कर पा रहे हो। कौन कौन लोग नहीं थे बाद में जो आए हों तो बोल दें। चैट बॉक्स में कुछ लोग लिख रहे थे ना बाद में। चलिए कोई नहीं। हाँ बताइए ऐश्वर्या। हाँ
सर, इंटरनेट की प्रॉब्लम बीच बीच में स्लो हो जाता है,
अच्छा
स्पीड
ठीक,
कम हो जाती है, वीडियो पॉज हो जाती है।
ठीक है। तो क्लास वगैरह तो ये जो आपको अपलोड की जाती है उसको देखते रहिएगा, नहीं उसको ना छोड़ दीजिएगा ना, इसीलिए यूट्यूब पे कर देते हैं नेट की प्रॉब्लम जो आती है। रिस्पॉन्ड किया करिए, सभी लोग एक साथ नहीं स्लो हो जाता हो, बच्चा लोग रिस्पॉन्ड करोगे तो हमें भी लगेगा हाँ सुन रहे हो ना। अब सब शांत रहेंगे, जो एक बोले तो वही बोले। सुन रहे हो ना आप लोग? रिस्पॉन्स इज रिक्वायर्ड। ओके,
Yes,
थैंक
sir.
यू। क्या क्वेश्चन था हमारा, कौन जवाब देगा? बोलना है। Who will answer it? जवाब तो कोई दीजिए एक जन।
Sir,
Yeah,
so what are different elements required for implementing any filter, digital filter?
good, very good. And what is the jawab? What is the response of this one? Speak, please speak.
Sir, adder, multiplier, any storing element
Good.
which can store the previous state.
Yeah, state. So when we design any filter or when we draw the architecture of any filter, then what happens? In that one, the basic elements that are required are the adder, multiplier, etc. here. So in order to see the architecture, which block of among these two has to be selected? Override generate filter block or filter build or build model using basic elements, which has to be selected? If we are interested in order to see the architecture of the filter, then which option has to be selected among these two? Is it visible, na?
Sir, build using build model basic
Very
elements.
right. Build model using basic elements. Name? Anshika Patel. So here we will select the build model using basic elements. And for that purpose, you can optimize for the zero gains, for unity gains, for negative gains, for delay change. And after selecting, here select the realized model. When you will select the realized model, then what will happen? Realized model means architecture, draw the architecture of that design filter. So what we are doing here, first from the given requirement, we have just calculated the values of the ripples in the pass band, ripples in the stop band, transition bandwidth, or we can say attenuation in the pass band, attenuation in the stop band, and transition bandwidth. And then we have to select here the sampling frequency. And after that, with the help of these 5 parameters, we have to derive the order of the filter. Okay. So from the design boxes, we will select the type of the response type. After that, what is the design method, then order of the filter, and then we will select the different ranges of the frequency. That is the pass bandage frequency, stop bandage frequency, attenuation in the pass band, attenuation in the stop band, and the sampling frequency. After this selection, we will design the filter. After designing, the next step is the analysis. Why the analysis is required? In order to see whether the performance of our designed filter will be as per the requirement given or not. Is there any deviation? Then naturally there is a need of the modification. And after modification, again we will design the filter and analyze the performances. Then for the purpose of the decision, to make the decision for the area as well as to decide the cost of the filter, there is a need of the architecture, that is the structure, filter structure. We have discussed that there are the different types of the realization of the filter, that is the direct form 1, direct form 2, cascade form realization, and the parallel form realization. These are the basic types of the realization of the FIR filter. And if we are in the FIR filter domain, then there is no need of the direct form 2 architecture. There is only one category, that is the direct form architecture. And for that purpose, means if we are interested in order to see what is the number of the multipliers, what is the number of the delay, and what will be the architecture, means how these adders, multipliers, and delays will be arranged, we have to select here this one option, that is the realize the model here. And from the realize the model, that is the dialog. Now if we use this one, then a dialog box will be opened, and in that dialog box we have to put the different information, and then we will select here the realize the model. After taking some time, we will get this block diagram here, having the input and the output that describes the filter here. If we are interested in order to see the filter architecture, now see here, this is the filter here. Now you can apply here the input and you can get here the output, and this filter can be used in any block diagram or in any model, and it is your designed filter here. And now if we are interested in order to see the architecture, then we will select here, we will double click on that block here, and we will get here the architecture of the filter here. See the architecture here, input, and the input is this is multiplied by the B1 coefficient, and then it is delayed, and then again multiplied by the B2 coefficient, and so on. See here, the order is the 10, and accordingly we will have the 10th order of the delay or the energy storing elements. There will be 10 states of the memory here. Okay, so this is the filter here, that is the first without any delay, first coefficient B1 without any delay. The second, after delay, it will multiply by second coefficients B1, B2, and the third or second, after second delay multiplied by the third coefficient, third delay multiplied by the fourth coefficient, and fourth delay multiplied by fifth coefficient, and fifth delay multiplied by the sixth coefficient, and sixth delay multiplied by the seventh coefficient, seventh delay multiplied by the eighth coefficient, eighth delay multiplied by the ninth coefficient, and the ninth delay multiplied by 10th coefficient, and here the 10th delay multiplied by the 11th coefficient. So there are the 10 memory states are the 10 delay devices, 11 coefficients here, and number of the multiplications. See here the number of multiplication 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 delays and 10 adders, 11 multipliers are required, and their arrangement is shown in this block diagram here, which has been derived from the design filter by using the basic building blocks. So this is, and we can see here the different values of the coefficients also here, that is from the analysis. If you see, then you will find the different values of the B1, B2, B3, and for that purpose we have to select which option. कौन सा select करना पड़ेगा इसमें? Yes, response please. in order to see the different filter coefficients, which has to be selected from the analysis menu. We will select the analysis, scroll down, and then we will select the filter coefficients here. And these are the filter coefficients: V1, V2, V3, V4, V5, V6, V7, V8, V9, V10, and V11. 11 coefficients are there here, right? And these are the unquantized coefficients here. So what we have done, or what we have discussed in this lecture, we have discussed that if the requirement is given, then from that requirement we have to derive the pass band edge frequency, stop band edge frequency, ripples in the pass band, ripples in the stop band, and accordingly we have to decide the transition bandwidth, and then we have to decide what must be the sampling frequency for the given filter specification. And from these 5 parameters, and what are these 5 parameters? Ripples in the pass band, ripples in the stop band, pass band edge frequency, stop band edge frequency, and the sampling frequency. We have to calculate the order of the filter. So these are the different types of the calculation that are required. 5 parameters has to be calculated, and after the calculation of the 5 parameters, we will calculate the order of the filter. And after getting these 6 information, now we will move towards the designing of the filter. That is, we will select the response type: low pass, high pass, band reject, or differentiator. And after this selection, we will select what is the design method, FIR or the IIR. And if we have selected any particular design method, then for that particular design method, there are the different types of the approximation. For example, if we have selected the FIR, then in the case of the FIR, there are so many methods, and we have selected the windowing method. And even in the windowing method, there are the different windows that are used for the purpose of the designing of the filter. Then we have selected a particular window, that is the Hamming window. And then we will select the order. We have to specify the order, and how this order will be specified, that will be calculated with the help of the 5 parameters, that is the pass band edge frequency, stop band edge frequency, pass band ripples, stop band ripples, or the pass band attenuation and stop band attenuation, and the transition bandwidth and sampling frequency. Then after this decision, that is by entering these parameters, we have to again enter here the pass band edge frequency, stop band edge frequency, attenuation in the pass band, attenuation in the stop band, and then we will design the filter. And after designing the filter, we will analyze the designed filter. Means what is the amplitude response, phase response, what is the amplitude and phase response, what are the position and locations of the poles and zeros, in order to see the stability. And we will also see the different coefficients, and then we will move towards the architecture of the filter. How the architecture of the filter will be achieved from this design filter. For that purpose, we will select here the realize the model, that is the here this realization model will be selected here. And for this selection, after this selection, there will be a dialog box that will be related to the model, and in this one we have to select the build model using the basic elements, and then we will select here the realize the model key, that is in the bottom of this dialog box. When we will press the realize the model, after certain time, a box block will be appeared having the input, output, and the filter name. And when we will double click on that block, then we will get here the architecture of our designed filter, that will give about the information here give the information about the adders, multipliers, number of the delays or the energy storing elements, as well as the coefficients. The coefficient, there are in particular case the filter order is the 10, so the 10 adders are required here, and 11 multipliers are required, 10 energy states, that is the memory devices, are required here, and 11 coefficients are represented as shown in this one here. In order to see the value of the coefficient, again we will move to the analysis, and from the analysis menu we scroll down, and then we will select here the filter coefficients, and the filter coefficients will be represented here. So this is about the today's lecture, and again I am requesting you people and suggesting you that please be sincere and if there is any problem then please ask. कोई मतलब नहीं कि अटेंडेंस आपकी हो रही है कि नहीं हो रही है, इससे मतलब नहीं। मतलब ये है पेमेंट आपको पे क्या करेगा कि आप कितना अटेंशन पे कर रहे हैं, ये वैल्यू है आपके एजुकेशन की या लर्निंग की। ये नहीं कि अटेंडेंस हम ले रहे हैं तो आप हैं, अटेंडेंस नहीं ले रहे हैं तो आप नहीं हैं। आपको ही अलर्ट रहना बेटा, इसमें कोई ये नहीं कि हम आपको पूछें तब आप बोलें। जब भी आप कभी भी आपको प्रॉब्लम होती है, कुछ भी होती है, आप तुरंत बोलें, तुरंत करें, क्योंकि आपके लिए ही सारे एफर्ट्स किए जा रहे हैं, आपको लिए सारे मेहनत करके, सारे अरेंजमेंट करके आप तक कम्युनिकेट करने की कोशिश की जा रही है। जो भी लेक्चर होता है उसको हम लेक्चर को इसलिए भी यूट्यूब पे अपलोड कर देते हैं कि जैसे अभी कुछ बच्चे बताए कि बीच में हो सकता है जिस टाइम आपका नाम बुला रहे हैं आप बोल नहीं पा रहे हैं, नेट नहीं है, कुछ नहीं है, तो अब आप उसको यूट्यूब से देखते रहें, रिस्पॉन्ड करें। ऐसा नहीं कि हमेशा प्रॉब्लम रहती है, जब भी आपको कोई भी प्रॉब्लम हो, कुछ भी हो, तो आप बात करें, लेकिन ये करेक्टली आप जो भी पूछा जाए उसको रिस्पॉन्ड करें। ठीक है, एनी क्वेरी? क्वेश्चन होना चाहिए, क्लास के बाद में क्वेश्चन होना चाहिए। क्वेश्चन नहीं होने से ये भी लगता है कि लगता है आप समझे ही नहीं। एनी क्वेश्चन प्लीज?